So the first data type that we're going to talk about is the primitive data type. This is where everything starts. All data types are built off of the primitive, so therefore you need to understand these. There are different data representations, right? We've already looked at some of them, so let's go in, and you probably already know the primitives, but I just want to make sure that you understand these are the primitive types. All right, so the first one is boolean. That has a literal truth value state to it. And an example is that it's true or false. That's it. There is the char, which is a single character. That single character can be any type of character. It can be a capital A, a lowercase z. It can be the ampersand sign. It can be an exclamation point. It can be a 1. It can be any type of symbol set, alpha or numeric, or also a symbol itself. Then we have string. That's a grouping of the characters that we just talked about. For example, hello world. There's the byte. Now, we already talked about bytes. If you go back to CS100, you know what a byte is. It has 8 bits in it. So a byte is a signed 8-bit 2's complement integer. You should know what that is from CS100. So therefore, examples would be 84 and -17. There's the short. That's a signed 16-bit 2's complement integer. So that would be an example of 872 to -304. Notice the difference between byte and short. Byte is 8, short is 16. So a short is what? It's 2 bytes. I just want you to hold that in your mind. When we get to the end of the numbers, we're going to talk about that. Integer. An integer is a signed 32-bit. Notice that my bits keep going up. 2's complement integer. Here, in this case, I have -69,723. That's an example of a 32-bit signed integer. How about a long? Take a look at the pattern. What do you see? I went from an 8 to a 16 to a 32. I bet you can guess this one. This would be a 64-bit 2's complement integer. So here's a really big number. This would be a long. How about a float? This would be a 32-bit floating point value. So therefore, notice that it has a decimal point in the number. How about a double? Well, that would be a 64-bit floating point value. And notice that we start getting into very large numbers or very small numbers. All right, so this is what I want to ask you. Ready? What patterns do you see? Think about it. What patterns do you see? Just look at the chart. See if you see some patterns here. You know, patterns tell you a story and they give you clues. It's very important that you start looking for patterns. Patterns help you in problem solving. Patterns help you to write code. Patterns help you to build solutions for your customers. Therefore, you're going to hear me talk a lot about what pattern do you see. All right, so here's our chart. And we want to then look at this chart and see what patterns that we see. All right, so here's our chart again. We see that the data types include numbers, strings, and booleans. Okay. These are your primitives, numbers, strings, and booleans. They're holding a single piece of information. That's it. That's why they're primitive. Does that make sense? So therefore, one integer holds one integer number. That's it. One character holds one character. One string holds one string. One boolean holds a true or false, one piece of value, one piece of data. That's it. The memory size is dependent upon the data type. Do you see that? Let's take a look at that. That's important. You might be wondering, well, why can't I just use an integer and a double? And that's it. And in some languages, that's what you have. In others, you can start to break it down and say, I don't need 32 bits. I only need 8. So therefore, I can use a byte. Instead of a double, because a double uses a lot of memory, instead of a double, I'll just use a float, which is 32-bit. In other cases, it's like, oh boy, yeah, I have a very, very large number, so I'll use a 64-bit number, which is a long. Knowing the difference when you're dealing with larger systems and a lot of information that you're dealing with is going to help you to select the right size. So it depends upon the language you're working in, what project you're working on, and the amount of information that you have to process that you then select the right size, the right little bucket for the memory that you need. If you always just go and grab, well, I just want a long or an integer, when really you only need a boolean or a byte, just imagine how that memory adds up. And on larger systems, that can have an impact. If you don't need a string and you can use a char, then use a char. If you only need one single character, then why would you use a whole string? It's going to use more memory. So let's look at the terminology. This is a primitive data type. These are primitives. So therefore, if you hear that out in the wild and you're reading books, you're reading articles, and you hear primitives or primitive data type, now you know what they are. These are the building blocks. So let's take each of the languages and see how it breaks down. Ready? All right, so these are our primitive data types. Let's take a look at our chart. Notice here I've got the language on the left, and then I have each of the data types specified. Now for the whole numbers, I just went ahead and grouped those together. And for the real numbers, which is a number that's going to have a decimal point, I put those over here and I grouped those together as well. So let's take a look. PHP has boolean, string. It has a way to deal with whole numbers, integers, and it has a way to deal with real numbers. JavaScript, notice that it does not handle integers. There is a way of doing it, but natively out of the box, it doesn't have a primitive built in. And we can look at Ruby. Ruby looks an awful lot like PHP there, doesn't it? It includes all of these. Python. Yep. How about C? Now, C is one of those to where it has all the data types, including you can break these down too for the integers, for the whole numbers. You can have a byte, an int, an integer, a short, a long. You can have a float and a double and so on. C#, Visual Basic. All of these, you can start breaking these down so that you can specify the buckets that you need, and that's important. When you're working in C, you're at a different level of programming, so therefore you need absolute control over memory. Making sure that you're allocating the right amount of memory is important. What are our takeaways? The basic building blocks of data are the primitives. Every language has primitives, period. So the primitives hold a single value. That's it, just one single value. It provides a representation for a string, number, and boolean, and each language has these building blocks. So now you know what primitives are.